Let's take a look at chapter 8.2, question D. It says, write out the first few terms of this series. So at n equals 1, we'd have 9 times 0.1 to the 1, which was just 0.9. At n equals 2, we'd have 9 times 0.1 squared. 0.1 squared is 0.01. So we'd have 0.09 and 0.009. What's our running sum so far? We'd have 0.9 and then add to that 0.09, so we get 0.99. And then add to that 0.009, so we get 0.999. So what does it seem is going on there? It probably converges to 0.99999 repeating. Seems kind of like that's how it's set up. And then part 2, what does the series converge to? Well, we know just from the numerical pattern it looks like that, but let's do some actual series math on this. Is this a geometric series? After all, it's got a constant to the n, so it looks like r equals 0.1. Our geometric series formula is the sum of r to the n equals 0 to infinity is 1 over 1 minus r when the absolute value of r is less than 1. If r is 0.1, then yep, that's true, so we're good there. But we don't have in the original problem n equals 0 to infinity, we have 1 to infinity, and we also have a 9 times, so we have to deal with that. Let's deal with the whole n equals 0 versus n equals 1. We can say that this is equal to r to the 0 plus r to the 1 plus r squared plus dot dot dot. And that's equal to 1 over 1 minus r. And I could say that's r to the 0 plus, and now write a sigma for that big batch, and say starting at n equals 1 to infinity r to the n, that's 1 over 1 minus r. So now we have a form that's more like what we have in the original problem starting at n equals 1. Then what else can we do? Well, the original problem has a 9 times in there. Before we do anything with that, let's move this over here. So we get the sum n equals 1 to infinity r to the n equals 1 over 1 minus r minus r to the 0. R to the 0, anything to the 0 is just 1. So now we've got something more like our problem, and now let's multiply it by 9. So that would be 9 times 1 over 1 minus r minus 1. So that's our original problem. We had the 9 in here, but it could be out there as well. So ultimately what we're getting is 9 times 1 over 1 minus r of 0.1 minus 1. So we get 9 times 1 over 0.9 minus 1. And we could write that as 1 over 9/10 minus 1, which is 9 times 10/9 minus 1, which is 9 times 1/9, which is 1. And so this geometric series converges to 1, but we also saw it converges to 0.99999, which means that 0.99 repeating is equal to 1, which might not seem controversial to Calc 2 students because you've been in the math education system so long, but that was actually quite a controversial thing hundreds of years ago, and even maybe in what, 3rd grade or something when you were learning about decimals, it might have come up because like 1/3 is 0.33333, and if you add that 3 times you get 0.9999, etc. repeating, but is that equal to 1 or not? There's even a Wikipedia page about the whole debate. Let's go take a look. So here's the Wikipedia page, and there's a bunch of different proofs, and one of them, skepticism in education. See, kids have been questioning this for a long time, but if we look in the text for the geometric, it's doing all those geometric calculations we just did.